Here we go, ladies and gentlemen. This is a review of your upcoming test. Um, if you follow along here and you have a clear understanding of what we're doing here, then you should do very well on the test that you're about to take, which is Thursday and Friday. Um, so the questions are mostly from your previous tests. I'm going over some of them because your upcoming tests have a lot of materials from the previous chapters as well. And then the remaining question comes from your homework assignments, which I handpicked personally because I have seen the test and I know what they're about to ask you. So please pay close attention. So this question is perimeter questions. They ask you what is the perimeter around Jamie's fence, right? So that means we need to find all the sides. We need to find the distance from A to B, B to C, C to D, E to D, F to D, and A to F. And then we're going to add up all the sides. To find the distance between 2 points, we know we can use the distance formula, which is x2 minus x1 squared plus, um, mm, let's try that again. Okay, so we know it's going to be distance is equal to x2 minus x1 squared plus y2 minus y1 squared. Okay, but lucky for you guys, you don't have to find the distance, 1, 2, 3, 4, 5, 6, 7 times, because notice we have a few lines that are just horizontal or vertical, so we can just add up those without actually using the distance formula just by counting the boxes. So if you're looking for the distance from A to B, it's just 1, 2, 3, 4. It's 5 boxes between A and B, so the distance would be 5. Same thing with AF, right? AF, you can just count 1, 2, 3. So that would be 3. ED is the same thing. From E, we go 1, 2, 3. That's also 3. So the only place we actually have to find, we have to use the distance formula is between C and D, B and C, E and F. All right, we're going to do it. We're going to plug the distance formula 3 times, basically, and then we should be in good shape. Let me just start by just finding the distance between, let's see, 1, 2, 3, between B and C. If I do the distance between B and C, then I need to find what point C is going to be. Point C we know is at 4, 2. Point B we know is at 0, 5. Is that? That's 0, 5. Okay, so we can call this my x1, y1. This will be my x2, y2. Actually doesn't even matter which is which. Just have to make sure you stay consistent and plug it in. So x2 is 4, so it's 4. Yep, it's gonna be 4 minus 0 squared plus 2 minus 5 squared. And yes, don't forget you taking the square root of the whole thing. 4 minus 0 is just 4. 4 times 4 is 16. This is 16 plus 2 minus 5 is negative 3. Negative 3 squared is 9. This is going to be the square root. What are we looking at? 16 plus 9 is 25. And the square root of 25 is going to be 5. So distance between B and C is 5. Notice what I know so far. I know the distance between A and F, A and B, E and D, and B and C. I need to find, I'm going to do the same thing again to find the distance between C and D. Okay. This turns out, if I do the same thing again, I get 5 again. Okay. I'll do the same thing here. This is, let's say 1, 2, 3, 4. 1, 2, 3. Okay. Oof. This is also 5. Okay. Now, if you don't see how I get these two numbers, that's okay. because all you have to do is use the distance formula the same way you did between B and C. You're gonna do the same thing between C and D, the same thing between E and F, and that should give you these numbers. Once you get these numbers now, the idea is, how do you find the perimeter? Well, we know perimeter means we're gonna add up all the side. So I'll start with this 3 right here. So it's 3 plus 5 plus 3 plus 5 plus 5 plus 5. All right, so what is that? This give me 15 plus that gives me 20. 20 plus 6 is, we're getting 26 units, whatever the unit is. Okay, so here, what are we looking out for? We're looking out for the distance formula. When can I use the distance formula? When do I not need to use the distance formula? If I have a straight horizontal line, I don't need to use the distance formula. If I have a straight vertical line, I don't need to use the distance formula. Anything that is slanted, though, I do need to use the distance formula to find the distance between the 2 points. Okay. Let's see. Question number 2 is asking you to find the equation of a line that passes through this point and is going to be parallel to this given equation, right? If it's parallel to this one, okay, the equation is 3x plus 5y is equal to 9. What do I need? I need to know two things, right? I need to know y is going to be mx plus b. In order to write the equation of my line, I need to find the slope. And I need to find b, which is the y-intercept. But how do I find the slope? I know the slope that I need is going to be parallel to whatever slope this is. What do I know about lines that are parallel? Okay, the rule says they're supposed to have the exact same slope. So if I can find the slope of this line right here, then this is going to be the same slope I need for my line. Notice I can't find the slope in this line and this equation the way it is. I have to rewrite this equation, right? How do I do that? Well, I'm going to subtract 3x from both sides. So I get 5y is equal to negative 3x plus 9. Okay. Then I'm going to divide by 5 everywhere. I divide by 5, I get y is equal to negative 3 over 5x plus 9 over 5. Now, important, what is the slope of this line? The slope of this line is the number in front of the x. Okay, so the slope of this line is negative 3 over 5. What is the slope of the line that I need? Well, the slope that line that I need is going to be negative 3 over 5 as well. It's exactly the same. Now, if the lines were perpendicular, I would have to do the negative reciprocal here. Now, how do I find B? Okay, how do I find B? There is something missing here. Right? At my point, there is something missing. Okay. Let's just say there should be the point should be -1. Okay, we're gonna make the point here -1, 5. -1, 5. Okay, let me go ahead and rewrite that. We're gonna say this is -1, comma 5. Actually, let's make it -5, comma 5. -5, comma 5. And I'm doing that so I don't have any decimals. Okay, because I don't see what the number is supposed to be. Okay, so here to find the y-intercept, I'm going to use the formula y is equal to mx plus b. Notice I know the slope. If I use this point right here, this is my x, this is my y. I can just plug those in right here. And we're in business. That would give, we solve for b and we're done. So what is y? Y is 5. So this would be 5 is equal to -3 over 5 times x, which we said was 5, plus b. Okay, negative. Okay, a lot of you guys struggle with this because you're not sure what to do. A lot of you guys struggle with this. What you want to do is you want to multiply across. Multiply this multiply that. When you do that, you should end up with 5 is equal to negative 5 times, I'm sorry, negative 3 times 5 um, is that a 5 or a negative 5? For x, x is a negative 5, I'm sorry. Okay, negative 5 times negative 3 would be positive 15, and 15 divided by 5 would be 3. So this would be negative 5 is equal to positive 3 plus b. Okay, now I need to solve for b. I'm subtracting 3 on both sides, so b is going to be 2. Okay, so I can go back and write my equation to be, I can go back and write my equation to be y is equal to negative 3 over 5x plus 2. Okay, now let me show you guys why a lot of you guys would miss this problem on the test. Okay, okay, we have all this done correctly. So I'm gonna erase some of this because I need some space. I need a little bit of space. On the test though, your choices would look like this. It would say, A is, 2x plus 3y is equal to 7. Okay. And then y would be, B would be 3x plus 5y is equal to, what is that? Is equal to, uh, 10 is equal to 10. Okay. And then C would be, I don't know. Let's say 3x plus 2y is equal to 5. I don't know. Okay. Now, when you see these, you will notice that none of them matches this for equation we have. That's because you need to solve these for y. When you solve these for y, they're gonna end up looking exactly like the formula you have. Okay. If you were to change, in this case, let's go ahead and change b. If you change b, you will subtract this over here. So you end up with 5y is equal to negative 3 plus 10. And then when you divide by 5, you get negative 3 over 5x, right, plus 2, which happens to be exactly the same thing we had here. So you might have to play around with your answers a bit, okay? Otherwise, you're going to end up not seeing what the right answer is, right? Don't just guess here. Make sure you take the time to change these so you can get what you're looking for. This question was on the test, and you guys did not do well on this one at all. And I think it's mainly because you guys didn't take the time to actually draw this out. Okay. So let's go ahead and draw this out. So what we have is our XY point. It says point P is located in the first quadrant. We know this is the first quadrant. So we're going to call this point P. P is reflected across the x-axis. Where's the x-axis? Where is the x-axis? This is my x-axis. Okay, it's reflected along that axis. So where is P prime gonna be? P prime is gonna be somewhere down here. Now we can go ahead and answer those questions. All the questions are based on the line segment. So what I'm gonna do is I'm gonna draw that line segment. Right? I'm gonna go ahead and draw that line segment. Line. Now the answers just make sense. Line segment P and P prime, this like segment, it's parallel to X. This is X. Is it parallel to it? No, it's not. It's actually touching it. So the answer cannot be A. Is it parallel to Y? This is Y. This is X. Yes, it will be parallel to it. So B is one of my choices. Is it perpendicular to X? The answer is yes, because it's touching X at a 90-degree angle here. How do I know that? Because it's a reflection over that line. Okay. So yes, C is also one of my choices. What about D? Is it perpendicular to Y? No, it's not even touching Y, so it can't be. So we say the distance from P to the x-axis is the same distance from P prime to the x-axis. The answer is Yes. Okay. Oh, this is looking like it's including D. Let's make sure we know that D is not included. Okay. Of course, the distance from P to the x-axis is the same distance from P prime to the, because how did we get P prime in the first place? To get the P prime, what we did was we counted how far away this was from this line. Then once we have that number, we did the same thing on the other side. So the absolute distance is gonna be the same. And they say the distance from P to the y-axis is equal to the distance of P prime from the y-axis. This is also true. Why is that true? That is true because notice we did not move P at all. No matter how long P was from the y-axis, is the same thing it's going to be down here, right? Because P stayed and the P and P prime are on the same line. So they're equal distance from the um, y and the x-axis. So that's a really good question that you guys really should be paying attention to. Okay. One thing I know that they're gonna ask you a lot in the test when it comes to transformation is, do you remember the difference between rigid versus non-rigid transformation? Do you remember the difference? Okay. Rigid transformation mean um size will stay the same. Size same. Okay. Non-rigid transformation mean size is different. Okay. Now, if I were to ask you to tell me which one of my four transformation is a non-rigid transformation, you would happily say it is dilation. Because we know the other three, reflection, rotation, translation, those are all what we call rigid transformation because they're only shifting position, but the size remain absolutely the same. Okay. All right, so we did this last class, right? Using a ruler and a compass, can you construct the perpendicular bisector? Right, very easy. How do we construct the perpendicular bisector? Let's see, I've never used. Okay, here we go. We'll just use it from here, right? To draw a perpendicular bisector, we have our line PQ. We want to make sure that our compass is over half. It's more than half. We draw a line from P. We draw an arc from P, top and bottom. Without changing the size of our compass, we draw the same from Q. And then you see where they meet. These are the 2 points you're going to connect together. Voila, that's your perpendicular bisector. Okay? I closed that kind of early. Okay? I mean, you get it. We don't have to worry about that too much. Perfect. Very good. Okay? So this is another transformation question. This is asking you, do you understand what happened when you rotate or dilate? Okay. When you rotate 90 degrees counterclockwise, what happened versus when you rotate 90 degrees clockwise? Okay. When you do this or that, right? So here, the easiest way to solve this problem is, let's take point A. If I have point A, what can I do with these four choices to go from A to A double prime? Right? Notice you have to do two things. You need to, so if I'm looking at A, right? First, I need to rotate 90 degrees counterclockwise. When I rotate 90 degrees counterclockwise, what is my rule gonna be? Okay. So let's say counterclockwise, meaning that the it's gonna be negative yx. Right. So I have to swap those and you know you get the work. All right. So go ahead and do that. Since we're running long on time, I'm gonna go ahead and you know run through this real quick, and then um no big deal here. All right, so here we're looking at these angles. Now this is talking about angle pairs. Do you remember your angle pairs? If you remember your angle pairs here, you would be okay. You are going to look at the angle pairs and ask yourself, what is the relationship between them? What's the relationship between them? Are they vertical angles? Are they alternate interior angles? Alternate exterior angle? Are they corresponding angle? Are they linear pair? Whatever it is, we need to know what it is. So here we have same side interior angles, and we know that same side interior angles always add up to 180 degrees. So if I'm looking for A here, I can say something like 2A minus 9 plus 5A plus 14 is going to equal to 180 degrees. From here on out, all I have to do is solve for A, right? This is basic algebra. I combine these two, I get 7A. I combine these two, what is that? Negative 9 plus 14 is what? Positive 5, if I'm not mistaken. Let me just run this to my calculator real quick. 14 minus 9, yep, positive 5 plus 5 is equal to 180. Okay, I'm subtracting 5 from both sides. Okay, when I minus 5, I get 7A is equal to 175. So what's A gonna be? A is gonna be 175 divided by 7. Okay, 175 divided by 7, and I get something like 25. Once I get A to be 25, this is when this gets fun, right? This gets real fun because they start asking you some interesting questions here. Okay, this was driving me crazy because I couldn't see. Okay. This starts to get real fun because here, what angle are they asking me? They're asking me to find angle ABQ. They want me to find this angle right here. Okay, I don't know nothing about angle ABQ, but I know something about ABQ. I know ABQ is the same thing as this angle right here because those two angles are what we call corresponding angles. So if I find this angle, it's going to be the same value for ABQ. So I can say 5 times 25 plus 14 is going to be this angle that I'm looking for right here. 5 times 25 is like 125, if I'm not mistaken. Okay. I don't want to make a mistake on this video, so let's make sure we use that. So it's 125 plus 14. So this right here would be 139, right? Perfect, right here, 139. Next, I want me to find angle BCR, this angle right here. Okay, let me use a different color for that angle. Okay, they want me to find angle BCR right here. But how do I find angle BCR? I don't know nothing about BCR, but I know BCR into A or what we call alternate interior angles. So they're going to be equal to each other. So I can say 2 times 25. What is that? Plus what? What's that? Minus 9? Minus 9. That's going to be the angle I'm looking for. So this would be 2 times 25 is 50. 50 minus 9 is what? 41. So my angle would be about 41 degrees. Okay, this is not a particularly challenging question, but it does require you to understand the relationship between the angles. These are angle pairs, but what are the relationship with the angle pairs? If there were alternate interior angle, what does that mean? If they're corresponding angles, what does that mean? If they're vertical, what does that mean? So we need to make sure we understand all of that. Okay, when are they corresponding and when are they supplementary? We need to find out. Again, this is another one of those, right? Here they're asking you to find angle Z. Angle AZB, I'm sorry, angle AZB is right here. But I don't know nothing about that angle. So how can I find that angle? Well, I know that this angle and that angle are vertical. If I can find angle 22y minus 101, then that would give me the same thing as the angle that I'm looking for. But how do I find that? Before I can find that, there's a y there. How can I solve for y? Notice that these three angles together form a straight line. And we know a straight line is always equal to 180 degrees. So I can say 11y plus 37 plus 22y minus 101 minus 11y, okay, plus 118 is equal to 180 degrees. Now all I have to do here is solve for My y. Okay, we're gonna combine like terms. We're combining this, this, and this. This is 11y. This is minus 11y. Those two will cancel each other. So I end up with something like 22y. I can combine this, this, and that to get something like plus, give me a second here. Let's see. 118 minus 101 plus 37. So this is 54. Yes, this is equal to 180 degrees. This thing is acting up now a little bit. It's all right. We're going to subtract 54 from 180. So we get 22y is equal to 126. Divide by 22. 126 divided by 22. We got let's say 5.7. I was hoping we got a whole number, but we didn't. That's okay. All right. So we said it's going to be 5.7. Once we get this to be 5.7, I'm going to go ahead and plug it into this equation right here. All right. I can come plug it into this equation because I know 22 times 5.7 minus 101. For a second there, I got scared because I thought the number was going to be negative. I was going to say, ugh, I think we made a mistake. Okay. So what do we have here? 5.7 times 22 is 125.4 minus 101. So we get about 24.4 is our answer. 24.4 is the angle right here, but we know this angle is the same thing as that angle that down there. So that one has to the angle we're looking for has to also be 24.4. Not too much here, as long as you understand two things: the linear pairs, and you have to understand how the vertical angles. And then you should be okay. I love this question. This was on the last test as well, I believe. No, this was on your homework. Okay, so here, before I can answer any of these questions, some numbers would be nice, which is why I'm gonna put in some numbers here. Okay, I'm gonna make up my own numbers. Okay, you can do the same if you want when you get to the test. I think on the test I'm gonna actually give you one of these numbers. Let's say angle four is 40 degrees. If angle 4 is 40 degrees, what do I know about angle 3? Notice 3 and 4 are complementary, which means if angle 4 is 40 degrees, angle 3 has to be 50 degrees. What do you notice about angle 4 and angle 1? They are vertical angles, which means this must also be 40 degrees. Notice angle 4 and angle 5 are linear paired, which means if angle 4 is 40 degrees, angle 5 has to be 140 degrees. It has to be 140 degrees. Okay. Now, how do I find angle 2? Notice angle 1, 2, and 3. Yeah, angle 1, 2, and 3 form a straight line, which means together they have to equal to 180 degrees. This is 50 degrees. This is 40 degrees. So that gives me 90. So by default, this has to be 90 degrees. This was a poor choice of a question, I think. My numbers didn't make sense, but that's fine. Now, because I needed the numbers so I can make sense of the choices, select all that apply. Angle 1 and 4 are adjacent. Let's look at angle 1. Angle 1 is 40 degrees. Adjacent means next to. Are angle 1 and 2 next to each other? No. But what do you know about angle 1 and 4? Angle 1 and 4 should be vertical, but that's not what they're asking you. Let's say angle 1 and 2 are complementary. Do you agree? Do angle 1 and 2 equals 180 degrees? No, they don't. Angle 3 and 4 are adjacent angles and complementary. Are angle 3 and 4 next to each other? Yes. Are they complementary? Do they add up to 90 degrees? Yes. So, yeah, this choice would be, all right, this would be true. I like that one. Angle 5 is a vertical angle to the combination of 2 and 3. Is that true? Okay, this is right here. Let's see. Oof. Okay, this is angle. Oh, this line is kind of ugly. Let's fix that. This is my angle. Is it vertical to these two angles? Okay, it feels like it. I think it is. So let's say yes. 1 and 3 are vertical. Do you agree? No, because 1 and 4 are vertical. 4 and 5, are they adjacent angles? Yes, because they're next to each other. Are the supplementary angles? Yes, because they add up to 180 degrees. Or the linear pair? Yes, because they are form a straight line. So I will select these three choices, right? 3 and 4 are adjacent and complementary. Check. 5 is vertical. It's a combination with 3 and 2 combination. Vertical, check. And yes, 4 and 5 are all the same. It's adjacent, it's supplementary, and it forms a linear pair. Please pay close attention to this question, especially the question that says select all. The reason those are tricky is if you miss one of these, you miss the whole thing. So you really have to make sure you are paying really, really close attention to what you are doing. So the next one is another construction telling you to construct an angle bisector. Okay, we can do that easy. Let's go ahead and follow this video real quick. It's gonna tell us exactly what to do. Okay, we start by drawing a line on both ends. All right, without changing the size, we do that. The place where they meet is where we're going to draw our thing. Okay, easy enough, makes sense enough, straightforward. We did these in class, so this shouldn't be a big deal. Okay, couple more to go. Number 10. Again, number 10 is pretty much the same as number 6. Okay, 10 is pretty much the same thing as 6. What is it asking you here? They need us to solve for A and find some particular angles. But how do we solve for A? That is the key. How do we solve for A here? We need to find a relationship between our angles. What do we know about our angles? Okay, these angles, if you remember, are corresponding angles. If they're corresponding angles, how do I find A? They're congruent. So we can say 7A plus 50 is equal to 14A minus 20. Okay, from here on out, all I have to do is solve for A, right? I'm going to subtract 7A on both sides. So I get 50 is equal to 14 minus 7 is 7. 7A minus 20. Add 20 on both sides. So we get, that's a 20. 7A is equal to, okay, it feels like I'm rushing. That's why it's not writing well. 7. Okay, now it's not working at all. Technical difficulty. So we're gonna do 7A, right? We know how to finish this. 7A is equal to 70. You know what I'll do? Let me just close this out, just reopen it. It's taking a while, but that's okay. Let's scroll all the way down to which one we're doing? 10. Go to 10. Nope. Go up one more right here. Let's go to 10. Yep. And now we have 7A is equal to 70, which means A is going to equal to 10. Once I find A is equal to 10, pay attention to which angle they're asking you to find, right? Because here, they're not asking us to find the angle they're giving us information about. They're asking us to find other angles, but we can find them because we know there's relationship between them. So here, they're asking us to find F and T. F and T is right here. Okay, what do you notice about these two angles? They're vertical, so they're gonna be equal to each other. So if you find 7a plus 50, that's gonna be the same thing as the angle you're looking for. So what's a again? A is 10, so it's 7 times 10 plus 50, and if I'm not mistaken, that's gonna be 120 degrees. Okay, once we know this is 120 degrees, finding KTU is fairly simple, right? We can either, if we're looking for KTU, we know that it's going to be linear pair with this angle, but we already know how much this angle is. We already know how much this angle is because this angle is the same thing as 7a plus 50. So this has to be 120 degrees. This is 120 degrees and you're looking for that angle. What is it going to be? They're from a linear pair. This must be 60 degrees. Simple as that. Okay. Last but not least, I can feel you getting tired of me, so let's hurry up and finish this one. They want us to find x, y, and z, right? We've done a bunch of these in class. You're going to find these two first, right? To find y. Y is a linear pair, so you can say 3y plus 8 plus 5y plus 4 is equal to 180. Okay, you do all of that. So you get 8y plus 12 is 180. And if I'm not mistaken, y is gonna be, let's see, what is, okay, so we have 180 minus 12 divided by 8. Y is gonna be 21 here. Once you get y to be 21, then it's a domino effect. Finding the other should be easy. So notice if I'm looking for z, I can say 3y plus 8 is equal to z. We know what y is. Y is gonna be 21. So what is z gonna be? Z is gonna be 21 times 3 plus 8. Z is gonna be 71. So how do we find x? You have options. You know z into 27 plus x from a straight line, so we can use a linear pair here. We know these are across from each other, so we can use a vertical angle here by setting them equal to each other. So we have a lot of options. All right, so this is it for the review. This is the last question. I was really trying to keep it under 20 minutes, 25 minutes at most, but I think I went over just a little bit. So um review this. If you are good with this, you are ready for the test. All right, and good luck and make me proud.